Hello students, today we're going to learn section 5.2, proving trigonometric identities. I will use the word verify on quizzes and exams. So proving is what the book uses, I will use the word verify. When we verify, we have to make sure that one side looks exactly like the other side. So that's what it means to verify. It has to look exactly like the other side. You only work with one side at a time, and you would want to start with the more complex side. All right. So here is example 1. We need to verify that the left side looks like the right side. So I'm going to make the left side look like the right side. I'm going to make this entire expression look like 2. Okay. So what we're going to do is first I'm going to work with the left side because it's the more complex side. It's more complicated than this. So I'm going to factor out x squared minus 1 and x squared minus 1. Notice it's in red. X plus 1 times x minus 1, x plus 1 times x minus 1. So this is equivalent to this is equivalent to this. I brought down our denominators. This could be reduced and this could be reduced. Now we have x plus 1 minus x minus 1. Distribute the negative. We have x plus 1 minus x plus 1. Combine like terms, x minus x, that's 0, 1 plus 1. There's your 2. So now I made the left side look like the right side. It looks exactly the same. Always put this symbol to tell me that you are done with your proof. Okay, you are done with your proof. You're done verifying. Example 2. So I'm going to make the left side look like the right side. A little bit more complex because we have addition, but you can go either way. It's just easier to start off with the more complex side. All right, so I'm going to change tangent x into sine x over cosine x. Cotangent is cosine over sine x. This expression is equivalent to this expression. Now what I'm going to do is to combine this, I'm going to need a common denominator. So I'm going to multiply this by sine x, cosine x, cosine x. So now you notice that we have a common denominator. I multiply by sine x over sine x because you're really multiplying by 1. Remember, we cannot change the value of the problem. Okay, so sine x times sine x is sine squared x. Cosine times cosine is cosine squared x. We have the same denominator. Now we can put the two numerators together because we have the same denominator. Sine squared x plus cosine squared x is 1. I'm going to now rewrite 1 as 1 times 1 is the same thing as 1. So 1 over sine x times 1 over cosine x is equivalent to this expression. 1 over sine x is cosecant x. 1 over cosine x is secant x. This is not exactly this, but multiplication order doesn't matter. So I can move the secant x to the front, the cosecant x right after, and now we have the right side, the left side looking like the right side. We are finished. We are done verifying. Example 3. Example 3. Now the more complicated side is this right side with the fraction. Again, think of common denominator when we have two fractions. So I'm going to multiply secant x plus 1 top and bottom, secant x minus 1 top and bottom. So once we do that, we will have a common denominator. 1 times secant x plus 1, secant x plus 1. 1 times secant x minus 1, secant x minus 1. We have a common denominator. When you multiply a difference times the sum of the same two terms, you get a difference of 2 squares. We have the same denominator. Bring it down. So now we combine like terms. 1 minus 1, that's 0. Secant x plus secant x is 2 secant x over secant squared x minus 1. Secant squared x minus 1 is tangent squared. Okay, this is a Pythagorean identity. Now I'm going to rewrite 2 secant x as 2 times 1 is 2 times secant x. It's still the same. Tangent squared is the same thing as tangent times tangent. We now have 2. 1 over tangent x is cotangent x. Secant x over tangent x, I'm going to rewrite as 1 over secant x times sine x over cosine x. And look, we almost have it. 2 cotangent x, 2 cotangent x. We just need the cosecant. Well, this cosine x and cosine x reduce. We have now 1 over sine x. And 1 over sine x is cosecant x. So now we have the right side looking like the left side. Exactly the same, exact order when it comes to the factors. Remember, write this symbol to state that you are done with the proof. Example 4. We have cosine t over 1 minus sine t equals 1 plus sine t over cosine t. Both are pretty much the same level of being complex. So I'm just going to choose the left side. What I'm going to do is I'm going to multiply 1, the conjugate of 1 minus sine t, because I just need one trig function on the bottom here. So I'm going to multiply by the conjugate, 1 plus sine t over 1 plus sine t. 1 plus sine t times cosine t is this. 1 plus sine t times 1 minus sine t is 1 minus sine squared t. 1 minus sine squared t is a Pythagorean identity. 1 minus sine squared t is cosine squared t. This stayed the same. Now from here, I'm going to reduce cosine t over cosine squared t is just 1 over cosine t. And you have 1 plus sine t over cosine t, and it equals the exact same expression on the right side. So again, write this to state that you are done. Example 5. Definitely the right side is more complex than the left, so I'm going to start with the right. I notice here that we could factor a sine squared x from this. So I factor out a sine squared x. You could just focus on that. So what's left is 1. Sine squared times negative 2 sine squared is negative 2 sine to the 4th x. Sine squared times sine to the 4th is sine to the 6th. Bring everything down. This here is equivalent to 1 minus sine squared x squared. If you factor this, this is 1 minus sine squared x times 1 minus sine squared x, which is 1 minus sine squared x squared. Okay, so now what's going to happen is this here, 1 minus sine squared x, is cosine squared x squared. This is now cosine to the 4th x times cosine x sine squared x. So cosine to the 4th times cosine to the 1st is cosine to the 5th x. So now we have sine squared x, cosine to the 5th x. And now the right side looks exactly like the left side. We are done. And this takes a lot of practice, so be patient and just keep on working at it. All right, example 6. I'm going to simplify this left side because it has a fraction. I want to get rid of this fraction. So what I'm going to do is I'm going to work with the left side. I know that cotangent squared u is cosecant squared u minus 1. Again, this is a Pythagorean identity. Over 1 plus cosecant u. This is a difference of two squares. So cosine squared u minus 1 is cosine u minus 1 times cosine u plus 1. This and this are equivalent to each other, so this reduces to 1. We now have cosecant u minus 1. I notice there's no cosecant here, so I'm going to rewrite cosecant as 1 over sine u minus 1 over 1. This is equivalent to this. This was a difficult problem. It took me a while to figure out, but what I notice is I'm going to need a cotangent. So I'm going to need a cotangent. So if I had a cosine here, cosine over sine is cotangent. So I'm going to multiply top and bottom by cosine, because what I want is I eventually want a cotangent to match with that. But again, if we have a fraction, let's find a common denominator. So I multiply cosine u over cosine u. Now this needs a cosine u sine u, so that's what I did here. Cosine u minus 1 cosine u sine u, and we have a common denominator. Cosine u sine u, same denominator. We could put the numerators together. I notice what I could do is I could factor out a cosine u. So I factored a cosine u out times 1 minus sine u. And I'm going to rewrite this as sine u times cosine u. So this, I factored out a cosine u. These are the same. Cosine u over sine u, well, cosine u over sine u, there's our cotangent. That's what I want. Now, I have this. I'm going to break up this fraction into two partial fractions. So 1 minus cosine u minus sine u over cosine u. This here is equivalent to this. I just broke it up. Well, 1 over cosine u is secant u. Sine u over 1 over cosine u is secant u. Sine u over tangent u, sine u over cosine u is tangent u. So from here, I broke this up into two partial fractions. And now we have the exact same order. The left side equals the right side. And remember to write, this symbol means you are done with your proof. You're done with the problem. Again, number 6 took a while, so that's towards the last part of your homework. All right, have a good day.